good to see that we have a lot of people that are just with previous environmental experience and just trying to learn air permitting for the first time. Really, that's what this class is designed for, is to for people just starting out in air, to give them an overview of how we do air permitting. So, our training agenda is going to start off with Clean Air Act history and background. We'll talk about different types of permits. Then we'll go into the permitting process. That's going to be the bulk of what our class is going to be about, is that permitting process. We'll talk a little bit about state-specific air permitting. We won't get into the details of every specific state that you are in, but we'll just talk in general terms of what the different states require. And if at the end, if anybody has any additional questions, we'll be here to answer them. First thing we want to go through is a safety moment. As you've probably heard today, we have the fire alarms going off in the building. I've been told that their fire sensors are very close to some steam vents, and so we've had a lot of false alarms. So if the fire alarm does go off, we've been instructed to stay in the classroom, and the 4C staff will come by and let us know if we need to evacuate the building. And if that is the case that we need to evacuate, I believe the escalators are the primary way to get to the first floor and down into the lobby and exit the building. All right. So with that, we'll first begin with the Clean Air Act history and background. We'll talk about the Clean Air Act history. We'll talk a little bit about how the Clean Air Act is structured and what that means for air permitting. We'll talk about the regulated pollutants that are in the Clean Air Act, and the derivation of the federal, state, and local air regulations as a result of that Clean Air Act. So back in 1955, there was a regulation that was issued called the Air Pollution Control Act of 1955. And this was really the very first air pollution law that was passed by Congress. And it really didn't do anything to establish any sort of air requirements. But what it did do is it funded research for scope and sources of air pollution, which laid the groundwork for the Clean Air Act, which was first published in 1963. So if you think about how the air was back in 1955, this was probably about 20, 25 years into the Industrial Revolution. There's no real regulations that are controlling air pollution, and so we entered in a time where we had a lot of smog, and so people were getting concerned about the air quality, and that's why they started funding the research for the under the Air Pollution Control Act of 1955. Then when they passed the Clean Air Act of 1963, it first authorized the development of a national program to address air pollution related environmental problems, and it also authorized additional research into techniques to minimize air pollution. So the 1963 Clean Air Act, it also funded the Department of Health and Environmental Waste Air Quality Studies. It established the U.S. Public Health Service. It published non-mandatory air quality, and it also established criteria documents for state use. So really this was the first, this original Clean Air Act of 1963 established the groundwork for the future amendments that took place for the Clean Air Act, and established the groundwork for all the air pollution control requirements that we have today. A follow-up law was published in 1967 called the Air Quality Act, and it authorized the enforcement procedures for air pollution problems involving interstate transport of pollutants, and it authorized the expanded research activities. So 4 years later, we have another law that was published expanding environmental authority and started to establish procedures for controlling air pollution. But the big one was the Clean Air Act of 1970. That's the one that everybody is most familiar with now. And that first established and authorized the establishment of the National Ambient Air Quality Standards for criteria pollutants. So for those of you that are working with air, we know that states are required to be in compliance with the National Ambient Air Quality Standards. A lot of times you'll hear the terms thrown around called non-attainment or attainment. And what that means is if you're in an attainment area, your area is meeting all the National Ambient Air Quality Standards for those criteria pollutants. If you're non-attainment, then then that area is not meeting the National Ambient Air Quality Standards for those pollutants. So at this time, they established air quality standards for sulfur dioxide, particulate matter, and in this case, originally it was just general particulate matter. Later on in 1987, they added PM10, and then 1997, they added PM 2.5. We established a standard for carbon monoxide, nitrogen dioxide, ozone, which in this case it was the NOx and VOC are considered the precursors, so those are the pollutants that are regulated for ozone. Originally they established an air quality standard for hydrocarbons, but that was later removed in 1983, mainly because of the ozone standard that controlled the VOCs. And finally, lead was added in 1977. So the Clean Air Act of 1970, outside of that National Ambient Air Quality Standards that it established, it also established requirements for state implementation plans to achieve National Ambient Air Quality Standards. So most states these days have a state implementation plan, and it's a plan for the state to establish regulations that will help them to meet the National Ambient Air Quality Standards. And the SIP is required to be approved by the EPA, and if the EPA says yes, it meets all the requirements of the Clean Air Act to maintain air quality standards, they'll approve it. The Clean Air Act of 1970 also authorized the establishment of new source performance standards, so your NSPS regulations under 40 CFR Part 60 for new and modified stationary sources. It also authorized the establishment of the National Emission Standards for Hazardous Air Pollutants, the NESHAP regulations, and it increased enforcement authority. It also authorized requirements for control of motor vehicle emissions. So this was the major starting point for what we know as the Clean Air Act of today. One other note about 1970 is in 1970 is when the EPA was formally established. So along with this regulation, we also consolidated all the environmental regulatory control under the EPA. So in 1977, there was the 1977 amendments to the Clean Air Act. This one authorized the permitting provisions related to prevention of significant deterioration. So all of your PSD major source permitting was established in 1977. And that's one type of our new source review air permitting programs that we'll talk about later. It also authorized provisions relating to areas which are non-attainment with respect to the National Ambient Air Quality Standards. So if you're not meeting the National Ambient Air Quality Standards, we have more stringent permitting requirements. So that was all developed in 1977. Then we have the 1990 amendments to the Clean Air Act, which authorized programs for acid deposition control. It authorized a program to control 189 toxic pollutants, including those previously regulated by the National Emission Standards for Hazardous Air Pollutants. Excuse me. So that would be our HAPs, our hazardous air pollutants. And originally it was 189, but H2S has been since removed from that list, so we're down to 188. And it established the federal permitting program requirements under Title V. So 1990 amendments created Title V of the Clean Air Act. It also expanded and modified provisions concerning the attainment of national ambient air quality standards. It expanded and modified enforcement authority, and it established a program to phase out the use of chemicals that deplete the ozone layer. So that'd be your CFCs, your chlorofluorocarbons. So that's history of how we got to where we are today with the Clean Air Act. The next thing we're going to talk about is go into the different titles of the Clean Air Act. So the 1990 Clean Air Act amendments had 11 different titles. This is a much expanded version of what we know as the Clean Air Act. But what's important is Title I is the non-attainment programs. That's where national ambient air quality standards get established. Title V, that's the other part that that's big, is that's what established our Title V permits. That's why we refer to our operating permits as Title V permits. But what we know as the Clean Air Act today is these 6 titles. So the 1990 Clean Air Act amendments rolled all of these titles into these 6 titles of the Clean Air Act. So Title I is our air pollution prevention and control. That's a lot of what we're going to be talking about with our respect to our new source review permitting. And Title V, which is our operating permits. Title IV, I left it out. I forget what exactly it was for, but it doesn't have to deal anything with air permitting, so not important for this class. Acid rain, there you go. So we have this nice little chart that shows how the 1990 Clean Air Act amendments got rolled into the original Clean Air Act. As you can see, some of the titles that were in the 1990 Clean Air Act amendments didn't directly relate to the title that is in the Clean Air Act, but parts of the 1990 Clean Air Act amendment amended certain parts of the title, other parts added new titles, and other sections just repealed portions of the Clean Air Act. So not exactly important for teaching air permitting, but it gives you an idea of how the Clean Air Act got structured. So here's a table that shows the different regulations that have been structured under the Clean Air Act. The section is the section that it is listed in the Clean Air Act, and the part is the regulation that was passed. It's the actual regulation that you can find the language for that specific rule. So our National Ambient Air Quality Standards is in 40 CFR Part 50, and it's also Section 109 of the Clean Air Act. Our SIP provisions are in Section 110 of the Clean Air Act and 40 CFR Part 51 of our federal regulations. One other thing to note, if the section starts with 100, that means it's associated with Title I. As you can see, our operating permits is sections 501 to 507. That's because it's in Title V. So Title I, Section 113, is important because it provides provisions relating to the enforcement of the Clean Air Act of 1990. So a lot of what we deal with in terms of enforcement is a result of this Section 113. A lot of the refineries went through Section 114 requests about a year or two ago. These are specific information requests requiring data for rule development or compliance determination. So a lot of the recent flare activity that the EPA is researching is coming under these 114 requests. Title I also contains a broad array of authorities to make law more readily enforceable, and the Clean Air Act amendments brings the Clean Air Act up to date with other major environmental statutes. So the Federal Clean Air Act Enforcement Authority gave the EPA authority to issue administrative penalty orders up to $200,000 or field citations up to $5,000 for lesser infractions. So what this means is that if the EPA finds an infraction on the spot as they're investigating your facility, they can give you basically what amounts to a traffic ticket of $5,000. Otherwise, if they decide that it's more serious than that, go to the court and they can issue penalty orders of up to $200,000 per occurrence per day. It also gave them the authority to commence a civil action and recover a civil penalty, and it brings criminal penalties for negligent endangerment and/or Clean Air Act violations. So this allows them to process these as felonies. It is issued by the by the EPA themselves. So I know the $5,000 infractions. It's really amounts to what a traffic ticket is. It's basically a citation that you are required to pay. I'm not familiar with how that relates to going to court to challenge that or not. So really what it amounts to is the EPA is given the authority to issue these citations, and I'm pretty sure that is outside of the court system. And second and third bullets, the commence a civil action, recover a civil penalty. So if they deem that it's serious enough, they can take you to court and get penalties that are above these $200,000 and $5,000 fines. So the structure of Title I under the Clean Air Act, we got Part A. I skipped out Part B because it's not relevant for this discussion. And Part C and Part D. Under Part A, we got our federal regulations here. So under Section 11, 112, and 109, we got our NSPS regulations, our NESHAP regulations, and our National Ambient Air Quality Standards. As a result of the NESHAP regulations, we got our MAERT requirements. These are your 40 CFR Part 63 regulations. As a result of the National Ambient Air Quality Standards, we got what we call reasonably available control technology. This is what is referred to as our state requirements for control technology. So a lot of states will issue their own specific control requirements, and that's what we refer to as the RACT rules. Part C is the new source review for attainment in unclassified areas. So this would be our PSD new source review permits. And likewise, under Part D, we got our non-attainment areas for new source review under non-attainment areas, and that's where we get our non-attainment permits. We'll talk about this closer to the end of the day, but under the PSD, we got our best available control technology requirements, and under the non-attainment permits, we got our lowest achievable emission rate requirements. So that's how the Title I of the Clean Air Act is structured. Title I of the Clean Air Act also authorizes the EPA to establish national ambient air quality standards. That's one of the common themes that we've talked about thus far. So for attainment counties meeting national ambient air quality standards, a new or modified reconstructed source must undergo a new source review and/or also called the Prevention of Significant Deterioration review before beginning construction. So that's the major groundwork for what we decide whether we need to obtain a federal permit or if we're looking at state only permits. For non-attainment counties not meeting national ambient air quality standards, a new or modified or reconstructed source must undergo a non-attainment new source review before beginning construction. So like I said a few minutes ago, if you're in a non-attainment county, you're going to have more restrictive air permits under the non-attainment new source review. If you're in attainment county, you're going to be looking at something that's less restrictive, which is the PSD program. So Title I of the Clean Air Act also authorizes the EPA to establish new source performance standards. These would be your 40 CFR 60 regulations. They apply to any new source that you are constructing, and it provides the control technology that you must meet when you construct that new source. Title I of the Clean Air Act authorizes the EPA to establish national ambient air quality standard, national emission standards for hazardous air pollutants. They're your NESHAP regulations. These fall under two specific regulations, 40 CFR 61 and 40 CFR 63. So 63 we often refer to as our MAERT regulations. Specifically 61 regulates specific pollutants. So when you're looking at the 61 regulations, you're going to be looking at regulations relating to specific pollutants. Most people will be most familiar with is the subpart FF, your benzene waste organic NESHAPs. 40 CFR Part 63 is more of a source type category. So if you operate a specific type of process, that's how it's structured under 40 CFR Part 63. Specifically, subparts F, G, and H are your SOCME, your chemical regulations. We have subpart CC and subpart UU, which is our MACT regulations for the refineries. And subpart 5D is probably one of the newest regulations, which is that boiler MACT that everybody is referring to and talking about these days. And it allows for future MACTs and uniform standards to be issued. So that's the titles of the Clean Air Act. Next up is regulated pollutants. Does anybody have any questions so far? Sources are defined in the actual regulation. I believe it's 40 CFR Part 51. Do you remember, Matt? Yeah, I think, yeah, 51 then. A source, and working in Texas, we have to deal with a couple different definitions. What Texas refers to as a source is not what the EPA refers to as a source. So EPA regulations, your source is your actual emission unit that's generating emissions, whereas in Texas, the source refers to the entire site as a source. When we talk about source in this class, we're going to be referring to the actual physical unit that is generating emissions. Correct. A heater, a boiler, process vent, a flare, something, loading operations. That's what we're referring to as a source in this case. Anybody else have any questions? Yeah, we'll talk about that in the second section. So regulated pollutants. Under Title I, regulated pollutants include our criteria pollutants, which is carbon monoxide, nitrogen dioxide, sulfur dioxide, particulate matter, ozone, which is our VOC and nitric oxides is our precursors, and lead. So under 40 CFR Part 51-100, we got a definition for VOCs. So if anybody's not familiar with what constitutes a VOC, it's any compound of carbon excluding carbon monoxide, carbon dioxide, carbonic acid, so a few other specific carbon materials that are not included in this list. Which precipitates in atmospheric photochemical reactions. So anything that contains carbon that can react within the in a photochemical reaction in the atmosphere. It also includes any such organic compound other than the following which have been determined to have negligible photochemical reactivity. So methane, ethane are a few of the specific ones that everybody is familiar with that are not considered to be VOCs. Another one that I see a lot of times that people confuse as being a VOC, which really isn't, is methyl acetate. But other than that, you can look at that list in the regulation to determine which specific hydrocarbons are not VOCs, but most of them are. Other regulated pollutants include our hazardous air pollutants, also known as HAPs. The current list of HAPs contain 188 pollutants, and for anybody that wants to go take a look at what that HAP list is, got a website link for you to see the original 189 HAPs, and if you notice, and if you go to that link and look up that dihydrogen sulfide, you'll see a note that says this has been removed from the list. So feel free to go take a look at that if you have some time. We also want to note that greenhouse gases is a PSD pollutant, is not a criteria pollutant, and it is, so there is no national ambient air quality standard for greenhouse gases. Under regulated pollutants or criteria pollutants, we got ambient standards. So there's federal, state, and local rules to meet ambient standards. It includes construction permits for major sources of criteria pollutants. So when you refer to our PSD permits, we have specific thresholds for each of our criteria pollutants. Hazardous air pollutants, there's federal rules to control, so there's no ambient standards. So when you think about our MAERT regulations, those are all regulations that are designed to control HAPs, and that's why we don't have specific ambient air quality standards for these, for the HAPs, that like we do for the criteria pollutants. We have state and local programs that can include ambient standards and or other impact standards. So the state and local programs can develop their own specific rules and their own specific permitting requirements for hazardous air pollutants. And there are some permitting requirements for hazardous air pollutants. You do have to, some states require you to list out the hazardous air pollutants specifically in your permits. Other pollutants that are referred to include NSR pollutants with no ambient standard, the acid rating program. There's some specific permits and or other requirements for the acid rain program that we're not going to discuss today. Ozone depleting substances, so your chlorofluorocarbons. That includes federal manufacturing use and disposal regulations. And then there's the greenhouse gases, which we currently have reporting requirements and some permitting requirements that are currently being discussed between the agencies. So that gives us the history, the titles, regulated pollutants, and now we're going to talk a little bit about the derivation of the federal, state, and local air regulations. So we've got federal standards that were established by the Clean Air Act, and the Clean Air Act also established our state implementation plans. So as a result of the federal standards, we've got our state implementation plans, which is a collection of the state regulations used to be in compliance with the federal standards. And so it's kind of a linear relationship. The federal standards or let me go back, work backwards. You got the state regulations that are a result of the state implementation, which is a result of our federal standards. So as a result of that, we have the the states are the ones that are required to meet the national ambient air quality standards. It is a federal regulation, but it's the states that are the ones that are tasked with developing the state implementation plan to be in compliance with the national ambient air quality standards. States and local air pollution control districts develop industry and mobile source rules to meet national ambient air quality standards. State implementation plan is submitted to and approved by the EPA. So once the state has developed the regulations to develop industry and mobile source rules, they've submitted to the EPA for them to approve it. And most state and local pollution standards and control requirements derive from the state implementation plan process. So that's what we refer to as our RACT rules. The Clean Air Act requires review by the EPA of the National Ambient Air Quality Standards every 5 years. So some recent changes to the National Ambient Air Quality Standards include the lead standard that was changed from 1.5 micrograms per cubic meter to 0.15 micrograms per cubic meter. So once we learned about the health impacts of lead, they reduced that standard. We got an annual PM10 standard that was actually removed. We've added 1 hour NOx and SO2 standards, and new standards have since been developed for PM 2.5. So looking at this table, yes?
They're talking about ozone now, aren't they?
Yes. I'll get into that in a second. So National Ambient Air Quality Standards table, this is kind of here listed for reference. You can find it on the EPA website. But it lists out all of the different standards that we have for the pollutants. So for an example, carbon monoxide has a standard, an 8-hour standard and a 1 hour standard with two different levels. As you can see under the ozone, we got a primary and secondary 8-hour standard that's 0.075, and that's the one that we're just talk about a little bit in, how they are looking to decrease that standard right now. So one of the things that has been going on over the last 10, 15, 20 years has been the reduction of the ozone standard. So we got our 8-hour ozone standard state implementation plan issues that have resulted from this. So July 1997, the EPA promulgated the 0.08 standard. August of 97, American Trucking sued the EPA, said that standard was too stringent. There's nothing, science doesn't back this up. And in February of 2001, the Supreme Court upheld the 0.08 standard. So they decided, no, there is sound science for this standard, and we're going to uphold it. In April 2004, the EPA designated their non-attainment areas under that 8-hour ozone standard. In June 2005, that's when the EPA revoked their 1-hour standard, so they had a separate 1-hour standard that they decided wasn't necessary to have. And then in March in 2008, EPA promulgated their 0.075 standard, and that's the one that we're dealing with now. This 0.075 standard changes the level, the averaging period, and method of determining when the standard is exceeded. So what that means is that if you look at this table, there's on the form column, it lists how you determine how you are meeting that standard and how it's calculated. And so that March 2008 change defined it a little bit differently than the 0.08 standard. So looking at the some of the non-attainment areas that are closest to us here in Austin, in Baton Rouge, they are marginal under the original 0.08, or sorry, marginal under the 0.075 standard, and they are attainment under the 0.08 standard. So they've met the 0.08 standard from 1997, but are currently not meeting the 0.075 standard. Dallas, Fort Worth, they're moderate under the .08, or sorry, the .075 standard, and are considered serious under the .08. What these designations refer to is it's basically a compliance timeline for when they can meet the specific standard. The longer it'll take for them to be in compliance with that standard, the higher the designation. So moderate would be a low level, serious would be, they realize it'll take a much longer time for them to be in compliance. Houston, Galveston, marginal and severe, and Beaumont, Port Arthur, they actually recently were labeled as attainment for the 8-hour ozone standards. Matt, do you remember when they approved that? I think it was like 3 or 4 years ago. All right, so that but that's one of the more recent developments, and they no longer have to obtain non-attainment permits as a result of that.
So imagine whenever EPA just put a new, they're discussing bringing it down to .06. So it's
2 slides.
all right.
This map shows where non-attainment areas. These are all the counties that are not meeting National Ambient Air Quality Standards. The different colors refer to the number of pollutants that they're not meeting the National Ambient Air Quality Standards. One thing I'd like to point out is, if you notice Southern California, they've got one county that has near LA, that is, actually I think that is LA, that is not meeting National Ambient Air Quality Standards for 6 of the pollutants, and a lot of them are not meeting the standards for 5 of the pollutants. If you're ever familiar with California, just the geography of that area, it's in a valley, they're surrounded by mountains, and the air has no way to escape that area, so a lot of the pollutants tend to build up in that part of the country, and that's why they're not meeting the standards for a lot of the pollutants. A lot of the Northeast, we've got a lot of industrial sources, and that's why there's a lot of areas not meeting National Ambient Air Quality Standards. Focusing nearby, Houston, Galveston, we're non-attainment for 2 pollutants, and really those 2 pollutants is the same one. It's both the .075 standard for ozone and the .08 standard for ozone. Same thing with Dallas. El Paso, nearby in Texas as well, they're non-attainment for only 1 National Ambient Air Quality Standard, and that one actually happens to be particulate matter, not necessarily because of the industrialized areas that you see around all these other cities that are not meeting National Ambient Air Quality Standards. It's more just dust in the air associated with that area. So map that's used for reference. Got another map here for the 1997 ozone standards. So these are the areas that are not meeting the .08 standard. And the color designates what level they are labeled as. Second map is the 2008 standard. So highlights the counties that are not meeting the 2008 .075 standard. And then, as we were talking about on the side, this map shows the proposed ozone standards for the .07 and .065. So .07 would be the darker blue, and .065 would be the light blue. And as you can see, there's a lot more counties than on these previous maps that is listed here. What this map doesn't show is the fact that there's a lot of counties in between all of these areas that would also fall under the .065 or the .07 standard, but they don't have any monitoring stations to verify that they are below or above those thresholds. So as we move forward, I believe was it .065 that was Yeah, that's a, so they've been talking about which threshold they want to use. The .06 has been talked about quite a bit, which would be even lower. I think they're starting to settle on .65, but they've proposed a range between .6 and .7.
On the bottom left, that's Big Bend National Park. Which is in the middle of nowhere. Nothing is there. Nothing. It's like the third least visited national park in the country. But not even people visiting. So that's one of those things that people are not happy about. It's like people don't even, there's not even cars there. There's not even seats there. So. Yeah, I guess. It's just one of those things that Texas is very much like, what are you going to do?
So when people say it will literally throw half the country into non-attainment, that's very true, and that's what this map shows us. Another reference slide here. This is just the EPA regions. So depending on where you're located in the country, you can you have your own EPA region that you report to. So here we report to Dallas. So we're Region 6 here in Texas. So that's kind of our intro for now. Gives you background, history, talk a little bit about the titles and how it relates to how it formed the regulations and the standards for our air permitting. And next section is we're going to talk about the different types of air permits. Some of your facilities, this might actually be true. You might have that many that your stack of air permits might be that tall. Hopefully yours isn't, and it's only a few pages. So the purpose of air permits, it gives permission to construct a regulated air emission source. It also gives permission to operate air emission sources, and it provides a summary of the requirements that your facility will be required to follow. So we'll get into a little bit more detail but I'll highlight the differences between the first two bullets quite often over the next several slides. The next bullet point, permitting authority. So some of your air permits will be authorized by the federal government, some of them will be authorized by the state, and some of them will have local air pollution control districts that you'll need to worry about. And we'll discuss the differences between those as well. So what triggers the need for an air permit? Permitting programs applicable to different types of emission sources. Usually the type and size of the emissions will determine whether or not you'll need an air permit. The more emissions that you have, the more likely you are to trigger permitting requirements within your state. The location of the source of emissions. So if you're located in a attainment county versus a non-attainment county, you might have different state requirements for air permitting. The type of industry. So if you're working for an oil and gas company, you're going to have different permitting limits than you would if you are working at a refinery. The applicability of specific rules. So if you're applicable to a specific regulation, that specific regulation might require you to register emissions. And then new or existing at the time of the regulation. So if your source is new versus an existing source, if that might determine whether or not you need to obtain an air permit. Types of pollutants regulated by air permits. So we talked about the criteria pollutants under Title I. Some HAPs will require air permits. GHGs are now requiring air permits, and sometimes states will require permitting for other pollutants that aren't necessarily listed here. And a lot of times that other categories, individual VOCs. So for an example, in Texas, we are required to identify all of our individual VOCs, and we'll do a health impact study on each of those VOCs to determine if we are allowed to emit those specific VOCs. So that other category is going to be not necessarily on the federal level, but more on a state and local level. So the size of the emissions, whether you're a major source or a non-major source, is going to determine whether or not you need to obtain an air permit. If you are a major source, you're going to need to evaluate your criteria pollutants against the each individual project that you do. You need to compare it to your major source thresholds, and so you'll have lower permitting or lower emission levels that will require air permits than if you were a non-major source. So if you're a non-major source, you're going to have higher thresholds, and so you might not be required to obtain an air permit if you are considered a non-major. And non-major sources can include synthetic miners or true miners. So what that means is that a true miner is you calculate all of your emissions, you're below major source thresholds. Synthetic miners can calculate your potential emissions for all of your sources, but you've identified specific areas where you're going to control the capacity of a certain unit, and that way, and you're authorizing specific lower limits than the capacity of the unit, and that's what we refer to as a synthetic miner to get us below those major source thresholds.
Where do we find those threshold limits?
They will be in the PSD requirements, and we'll actually go into those specific major source thresholds today. So don't worry, we'll get there eventually. We just want to keep building up our information and kind of getting in more and more details as we go along. So under types of air permits, whether or not you're required to obtain an air permit is going to, and what type of air permit you're going to need is based on the location. So that common thing that I keep talking about, the attainment areas versus non-attainment areas, they're going to have different permitting requirements. In which state your source is located. So in Texas, we have a very well-defined minor source air permitting program. All minor sources have to be authorized in some way, shape, or form. In other states, if you're emitting less than 25 tons of any criteria pollutant, they don't care whether or not you have an air permit or not, because there's no federal requirements for lower thresholds, and the states don't want to have to deal with, they don't have the manpower, especially your smaller states out in the plains and out west, and so there's no reason to obtain state permits for those sources. So the location of where you're at will determine whether or not you need to obtain state permits. The type of industry, so category niche app standards that can trip air permitting requirements. Power generation often comes under Title IV, or is referred to as a Title IV permit. What? Yeah. And so that's something that we're not going to cover in this class, but just something to think about. The type of industry that you're in might trigger specific air permitting requirements that not everybody is familiar with. Applicability of specific rules. So if you are NSPS applicability, that might trigger some specific air permitting requirements. MAERT area sources might also trigger some specific air permitting requirements as well. And then we talked about new or existing at the time of the regulation. So the federal and state programs, if you have an existing source, a state program state regulation might come into effect after you've already built your source, and so you won't necessarily have to obtain an air permit for that existing source. But sometimes the new regulation will require air permits for grandfathered sources. So a lot of the air permit, whether you are required to obtain an air permit that falls under this section, is not as frequently. You're not necessarily going to fall under the category of some of these requirements, because a lot of the regulations that or almost all of your emission sources that are new or existing are all required to have air permits at this time. Where you'll find is those states that don't have the air permit requirements for their minor sources, if they eventually pass regulations to permit their minor sources, then you would fall under this category of new or existing at the time of the regulation and be required to obtain your air permits. Last bullet point under this is the operating permits. So your Title V operating permits, all current sources that are that you operate, if you're applicable to the Title V operating program, you'll be required to obtain an air permit. And really that means whether you're grandfathered or not. So the federal, let me back up a step. This next set of air permits, what determines whether you're going to need an air permit or not, is going to focus more on the federal versus the state versus local. So federal permitting programs, that's going to be your PSD permits, that's going to be your non-attainment permits, that's going to be your Title V permits. They are all designed around federal regulations. And oftentimes, as the next bullet point talks about, your state permits for the federal permitting programs. So most of the states, I think 47 of the states, actually under their state implementation plan, issue the federal permits, your federal PSD, non-attainment permits, your Title V permits. And so this could be your state designated as the federal authority of the state program. What that means is that under your state implementation plan, you've developed all the procedures to obtain your PSD permits, your non-attainment permits, so that you have specific state regulations that you must meet to obtain those federal air permits. And the second bullet point is the state implementation of the federal program. So there's a few states that where they don't have a SIP in place for their PSD non-attainment permits. And so they have been designated by the federal government to issue permits based on the federal regulations themselves. So for the states that don't have the federal permit program, and like I said, I think there's about 3 of them that don't, the EPA will actually issue their permits. And then the rest of the states, they fall under one of the 2 categories. They either issue permits based on their SIP, or they are issuing permits based on the federal program. And so the next bullet point, state-only program. So once you get outside of these, your major source permits, your PSD non-attainment and Title V, there will be state-only permit requirements. And these are going to be referred to as your minor source permits. And each state has different requirements on what they state is needing an actual permit to operate in that specific state. And then finally, local-only programs. So if you are in a major city, some major cities require you to obtain an air permit from that city. And a lot of times those types of permits are not necessarily, I'm going to calculate all my emissions like I would for all my other permits, but they just want a notice saying that you're going to construct an air pollution source of some sort. So one of the best examples is in Chicago. One of our other instructors in the experts class, he always talks about if there's an air emission source that needs to go in Chicago, they have to obtain a permit from the EPA. If it's a major source, they need to register it with the state. They also need to register with the county, because the county is a local-only program that they have to obtain authorization for. And then the fourth one is they have to register it with the city of Chicago. So in that case, if you're constructing an emission source in Chicago, you're obtaining 4 air permits for your one source. So depending on where you're located, you might need to obtain a local air permit. On the next section, what determines what type of air permits you're going to need. Construction permit is required when you have a new facility, a physical modification of an existing facility, or a change in the mode of operation. So what this is referring to is your federal requirements, federal definitions of what constitutes a new facility, or a construction of a facility, what requires you to obtain an air permit. And so they define new facility, they define what is considered a physical modification of that existing facility, and they define a change in the mode of operation. So for an example, you're at an existing chemical plant, and they want to, at that plant, swap, maybe they want to change part of the process. They've discovered a way to make that process more efficient. So there's going to be a physical modification to some of the process vents in that facility. That is something that would require you to obtain a construction permit. Change in the mode of operation. Let's say you are loading out material and they want to change how they are loading that material. Maybe you're permitted for loading out material at maybe the material is heated to 100 degrees Fahrenheit, and now they realize that, well, they need to load it out at 150 degrees Fahrenheit. Well, that is a change in the mode of operation. That's something that's going to increase emissions, and that's something that you'll need to evaluate to see if you need a construction permit. Yes? Yes. And I could almost quote you the definition in the Texas regulations, but it's in this Texas regulations, it's a modification that results in the increase of emissions. And a lot of the different states have very similar language regarding physical modifications and increase in emissions. Specifically with Texas, I also know that if you've made representations in your application that you are changing and you haven't represented in the past, that is something that would require notification to the state. But because there's no increased emissions, it doesn't necessarily result in you obtaining a new construction permit.
May not be that clear either. I remember there was a client we had once that they installed a new digital control system on their power, was not changing any of the equipment, but because they were going to be able to operate more efficiently, they were going to have increased actuals upstream and downstream, so therefore there can be a little confusing.
A lot of times we'll get questions on, I'm going to go back to the loading example. They want to load something at a higher temperature, but in order to not increase emissions, they'll back off how fast they are filling a container. So that'll result in they'll balance it so that there's no increase in emissions. Well, that's still something that they'll still need to notify their state because it's a change in the representation that they've made in their previous permit, but they won't need to evaluate under the federal construction permits because there's no increase in emissions. So there's a little fine details that go into that, and a lot of that gets covered in the first day of the air permitting for experts class. So depends on this type, size, emission levels, location, timing of the project or modification. That will determine if the permit is required, and if so, what type. Determines if the federal, state, or local authorities are involved in the permitting process. So that's the common theme throughout this section that we're referring to. When do you need an air permit? Well, it kind of depends on where you're located, how much are the emissions, when is the project occurring, because federal regulations come into effect at different points in time, and so if you're constructed before a federal regulation gets implemented, you might not need a permit because of that, but if you construct afterwards, you would. And so that's the general theme of this section. Specifically PSD, this prevention of significant deterioration, these are your attainment area permits. It's a federal and state program, so it's either, it's listed out in the federal regulations, but your state implementation plans are the ones that are authorizing and issuing these permits. It applies to attainment areas, and it applies to major sources. So you need to make sure that the first thing you're going to be doing is determining whether or not you're a major source at your facility, and that'll determine whether or not you need to look at PSD construction permits. So if you're a new major source, you would definitely fall under PSD. If you're making a major modification at a major source, you would also trigger PSD permitting. And we'll talk about what those specific thresholds are a little bit later. We're actually on the next slide. So major sources under the PSD program includes stationary source with PTE greater than 100 tons per year. And PTE stands for potential to emit. And this is for your listed sources. So last bullet point kind of touches on a few of them. Electric steam plant over 250 million BTU per hour, refineries, chemical process plants, they all come under the listed sources. For unlisted sources, it's a stationary source with a PTE greater than 250 tons per year. A lot of your oil and gas wells, if you're working for an oil and gas company, you're going to fall under the non-listed category, and you're evaluating your emissions under the 250 tons per year for a major source. If the source is major for a non-attainment pollutant. So what this means is that if you are a major, if you have a non-attainment pollutant, you're going to have a lower major source threshold under the PSD program than you would for the under that 100 tons per year or 250 tons per year. So if you're in a non-attainment area, you're going to have a lot more stringent regulations. Greenhouse gases are not included in this category, and that is because for greenhouse gases, there is a separate limit based on global warming potential. So you are calculating your emissions of all your greenhouse gases and multiplying them by a global warming potential, and that gives you your emissions on a CO2 equivalent basis. So after July 1st, 2011, we have that same limit of 100 and 250 tons per year of greenhouse gases on a mass basis. But if you calculate your emissions and you're below 100,000 tons per year of CO2 equivalent for new sources and greater than 75,000 tons per year of CO2 equivalent for modifications, you won't be required to obtain a PSD permit. In this case, source refers to the entire facility. So when we're talking about these, the PSD permits, the major sources refer to the entire facility that you're at. So one thing to note, there is a very, very rare instance that you might actually fall above the 100,000 or 75,000 tons per year CO2 equivalent and still be under the 100 and 250 tons per year on a mass basis. So the mass basis is your individual greenhouse gas pollutants, and the CO2 equivalent is the mass basis multiplied their global warming potential. There's a few chemicals out there in one-off industries that if you multiply your tons on a mass basis by its global warming potential, you'll actually be above the 100,000 tons per year, but still under that limit. So kind of just a one-off fact about your greenhouse gases. And I believe that was, it's a sulfur type compound. Yeah, there you go. So, yeah. Listed in the federal regulation. And really, for the people that we've taught this class for, almost all of them fall under the refineries or the chemical process plants or oil and gas plants. So we list out those specific sources because almost everybody falls underneath, and make sure to mention the fact that the oil and gas sources are that 250 tons per year category. But good question. It is listed in the federal regulations. Yeah.
Well, some, be careful about refineries defined about the places. Yeah, I'm trying to.
Good, very good question. So application basic elements for a PSD permit. The first thing is you'll need to calculate your net emission increase, and we'll talk about how you can do that second half of the day. You'll need to include how you are meeting what is called best available control technology, BACT. So there's specific requirements for that. Again, we'll talk about that later. Impact modeling. So if you trigger PSD, you'll have to model your impacts on the on how it affects the national ambient air quality standards for that area. Will your impacts from constructing that major source still allow that area to meet national ambient air quality standards? And an impact assessment, you'll take a look at how that project will impact surrounding areas. Will it generate additional emissions from vehicles that are going to be going to your site now because you're constructing a new major source? That's one of the things that assessment will include. One thing to talk about with the impact modeling is the sorry, losing my train of thought. With the impact modeling, you're going to model your pollutants that are only applicable to the PSD program, and any state-only modeling that you're going to be required to do might fall under something else, under state regulations. So this type of modeling is specific to the PSD program. Major modification, so it applies to major sources. So if your source is an existing major source, if to trigger a PSD permit for an existing major source, you have to have a major modification. And so is the project emission increases above significant impact levels. And we'll get into what those significant impact levels are later. But the important thing to remember is that to trigger a PSD permit for an existing major source, and that's that one that's greater than 100 tons per year, is if you calculate your project emission increases, and if they're above the significant impact levels, then you are triggering a PSD permit. And that's the first step in determining whether you trigger PSD permitting. The second step is once you trigger that significant impact level, you look at your contemporaneous period, and often referred to as netting. You'll go through this netting exercise. And what this does, it calculates all of your project emissions, increases and decreases are compared to the significant impact levels in that netting period. And so if those levels are above the significant impact levels, that's when you finally do trigger PSD permits. One thing that we like to point out is that a lot of states will go straight to that second step, that project netting, or netting for that specific project, and see that in your netting contemporaneous window that you are above the significant impact levels and want to say that you are applicable to the PSD program. But if your individual project is not above those significant impact levels to begin with, you never have to go to this second step to determine if you are applicable to PSD. Because your project wasn't significant, you're not applicable to that PSD program. So an instance where that might occur is, for example, if VOCs are 40 tons per year, you have increased VOCs by 40 tons, 40 or more tons at your site. But in that contemporaneous window, you've done several projects over the last 5 years that result in decreases at your site. And so your contemporaneous period over that 5-year period is actually below that 40-ton threshold. So if you've done projects to deconstruct some emission sources, that is one way you would not trigger a PSD permit. The second type of construction permit under the federal program is the non-attainment new source review permitting program. Like the PSD program, it's both federal and state program. It's federal regulations determine your applicability, and the states implement that. And where it differs from the PSD program is that it applies to non-attainment areas instead of the attainment areas. And it also applies to major sources modifications. The difference being that the major source thresholds for non-attainment permits are much, much lower. So the basic requirements for non-attainment permits, you're under the non-attainment rules, you're non-attainment by pollutant only. So major sources are determined on a pollutant by pollutant basis and applies only to that non-attainment pollutant. That is major. So unlike the PSD program, in the PSD program, if you are you can be a major source under any one of those pollutants. And let's say you are a major source under the VOCs, you're greater than 100 tons of VOCs. If you can trigger your major modification for NOx because you're a major source for VOC. So you'd look at your significant impact levels. The non-attainment permitting program is slightly different in that it's a pollutant by pollutant specific. You have to be major for the pollutant that is determining non-attainment applicability. The other requirement under the non-attainment permits are the lowest achievable emission rates, which will describe the differences between how that is different from best available control technology. And what this talks about is it's the lowest rate feasible or demonstrated anywhere in the world to, that's the control requirements that you would need if you triggered non-attainment permitting. And one of the biggest differences between that and BACT is that you have to install this technology regardless of the cost. You must offset your increases in major non-attainment pollutants with greater decreases. So refer to offsets with non-attainment permits. If you trigger non-attainment permitting, you have to purchase the offsets from sources within your non-attainment area to obtain your non-attainment permit. So that's one of the biggest changes from PSDs is the control requirements and the purchasing of offsets. So the next category, state construction permits. It applies to non-major sources. It's not required by federal regulations, so there's no federal regulations covering whether you need a state permit. It's all within your state regulations. All states have different programs to authorize their sources, and they can be required for even the smallest of emissions depending on your specific state. So then after those permits, we got, those were mostly the construction permits that we were referring to. We also have operating permits. So your construction permit is required in order for you to construct your emission sources. Your operating permits are required to actually physically operate your source. It's based on the federal Title V program, and it applies to major sources under Title V. Some of the states also have their own local major source, minor source Title V operating permits. So depending on how your state is operates their permitting program, you might actually be required to obtain a Title V for non-major sources. And one of the ways that gets triggered is in Texas, for an example, we have two permitting programs. We have one permitting program for new source review, and we have one permitting program for our operating permits. And so Texas doesn't require our minor sources to obtain operating permits. Louisiana is very different. In Louisiana, they have one permitting program for both their construction NSR permits and their Title V. It's one permit altogether. So they are required to obtain Title V operating permits for their minor sources. So looking at your state regulations, you'll need to figure out whether you are required to obtain a construction permit under the NSR program and whether or not you're also applying for your Title V program at that state level as well. So Title V refers to federal operating permits, the federal operating permit program. Sometimes they're also called Part 70 permits based on the federal regulation that they fall under. It applies to major sources. For that, that's the federal requirement is that it applies to major sources. It does not replace the construction permitting program, and it is completely different than the PSD and new source review permits. They are state-run but federally enforceable. So the states issue the Title V permits, but it's important to know that they are federally enforceable. So if you are in violation of federal regulations, if you're in violation of your permits, it's the EPA that can come and issue the citations. It requires monitoring, record keeping, and reporting requirements. So the Title V permits contain all of your federal regulations. It also contains specific monitoring requirements for your emission sources. It also details what kind of records you need to keep and when you need to report them. And oftentimes there's a certification of compliance that is associated with the Title V program. Once a year, you'll need to certify that you are in compliance with your Title V permit. So what the Title V program does is it's a program designed to standardize air quality permitting process for major sources of emissions across the country. It enables the state, EPA, and the public to better understand source compliance requirements and whether they meet those requirements. And it gives accountability to the source and in turn enhances air quality planning and control. So by listing out all the federal requirements, state requirements in your Title V operating permit, anybody in the general public can look up your Title V permit and see, oh, they're required to have an IFR on their tanks, on their specific tanks. It allows the public to know that what are the reporting requirements. They can look up the state and federal regulations, reporting requirements, and see that your facility is required to submit a semi-annual report for a specific regulation that they're applicable to. So it gives everybody an understanding of what requirements are required for your facility and publicly lists it out so that it's easy to determine what your requirements are. It's important to know that Title V applies to major sources unless your state has a minor source permitting program for Title V. So it applies to a facility that emits or has the potential to emit emissions of any national ambient air quality criteria pollutant, hazardous air pollutant, or greenhouse gases at any level equal to or greater than the major source thresholds. And the Title V regulated pollutant list is slightly different than the criteria pollutant list of the construction permits. We have a few other pollutants that are regulated under Title V. So we still got that CO, the NO2, the SO2, PM10 and 2.5, ozone and HAPs. Those are all your criteria pollutants. But it also includes sulfur-related compounds such as sulfuric acid and hydrogen sulfide and our greenhouse gases. So under Title V, the thresholds are similar to the construction permitting thresholds. Your criteria pollutants still have that 100 tons per year threshold. Your greenhouse gas emissions have a threshold of 100,000 tons of CO2 equivalent, similar to the construction permits. Any HAP, this is where it gets a little bit more specific. So any one specific hazardous air pollutant has an individual limit of 10 tons per year that would trigger Title V permit. Or total HAPs, so you add up all of your HAPs together. If that is greater than 25 tons per year, you would trigger Title V permitting requirements. And then anything else that's not listed in this list has a 100 tons per year threshold. So like those sulfur compounds that we listed in the slide before would fall under that category. It's also important to know that for non-attainment areas, that threshold is lower. And that's where this slide comes into play. So if you're in a non-attainment area, you have lower major source thresholds. So depending on your designation for ozone, so we talked about the different designations when we showed the maps. If you're severe, you're going to have a lower limit. And the reason for the lower limit is that because they know that area is going to take longer to come into compliance with the National Ambient Air Quality Standards, they want you to have a Title V operating permit in place so that everybody knows what your requirements are. So 100 tons per year is going to be the same for your marginal and moderate areas, but once you start getting into serious, severe, and extreme, you get lower classifications. We have not applicable here for CO and PM10 because there is no marginal or severe extreme areas for CO, PM10 non-attainment areas, and just the same, there's no non-attainment classifications for SO2, NOx, and lead at this time. So operating permits, like I said on about 10 slides ago, there are some state operating permits which apply to non-major sources. And like I said, each state is slightly different. The requirements, applicability requirements are different, and the type of permit that you need for an operating permit for a minor source in an individual state is a little bit different. In some cases, with your federal operating permits, you'll list out all your regulations. In a state minor source operating permit, it might just be a notification that you're going to be operating that source. And that's why the application requirements for these state operating permits are going to be slightly different. So the best advice I can give you is to know your state requirements for your operating permits, know how your state operates, your permitting requirements. Each state, I think these days, has their own website that will spell out what types of emission sources will require these state-level operating permits. So to review, we've talked about the difference between federal, state, and local regulations and how that changes our permitting requirements. We talked a little bit about how major sources are applicable to your PSD, non-attainment, and Title V permits versus the minor sources, which are authorized by the state level construction and operating permits. We talked didn't necessarily talk too much about construction versus operating permits, but the important thing to know with that is that your construction permits are your PSD, non-attainment permits, and your operating permits are Title V. And your construction permits you're going to need before you start construction, and your operating permits you'll need before you actually start operation of that unit. And we talked about federal versus state. The EPA oversees the PSD non-attainment permits and gives the authority to the states to implement those permits. And in other cases, the states with your minor sources will have their own individual permits. So with that in mind, it's a little after 10 and have our first break. So feel free to get up, walk around. Yeah, questions first? What? Yeah, that's. Good. Good. So did everybody hear that? I'll repeat it. Greenhouse gases by themselves cannot trigger Title V permitting requirements. You have to be a major source under another pollutant in order to be a major source under greenhouse gases. And that was based on the court ruling last year, done before we developed the course. One of those things that we need to update. And you'll find that, and that's a good point, that you'll find a lot of these permitting requirements are ever changing as we get new regulations. Like we mentioned, the changes to the ozone standards are going to throw a bunch of new non-attainment counties into requiring non-attainment permits. And so we'll start seeing a lot of these other states that didn't have non-attainment regulations written into their state regulations will now have to write them into their state implementation plans, and so you'll start seeing a lot of changes in the next 5 to 10 years. Any other questions before we break? All right, I believe we got most of the people back from break. Two things I thought of while we were on break. One was a result of a question. So I'm going to back up a little bit, quite a bit. So I think I mentioned this once before, but I just want to make sure everybody knows, this National Ambient Air Quality Table is not something that, as you are preparing your permit applications, you will be dealing with on any part of your application. It's the states that determine if they are in compliance with the National Ambient Air Quality Standards. And so the state is determining whether they are meeting these standards or not, and that is what determines if you are non-attainment or attainment. So we specifically stated out so that you're aware of it, that this is going on behind the scenes, and this is what's triggering your non-attainment versus non-attainment areas. And then the second thing I thought of that I usually remember to mention, but this time I forgot. Can anybody think of a specific instance where you might be a major source under Title V, but necessarily a major source under the PSD program? You saw a lot of the limits were 100 tons per year. Anybody answer that question? Well, if you look at here, under the Title V, we saw later on that the major source thresholds for your criteria pollutants are 100 tons per year. Well, if you are a non-listed source, such as oil and gas well site, your stationary source is going to have a major source threshold of 250 tons per year. So if they're in between that 100 tons and 250 tons per year, they're going to have to obtain a Title V permit, but they won't necessarily have to obtain they won't necessarily be a major source under the PSD program. So kind of those little small details that you can pick up. So that'll bring us to the next section, which is our permitting process overview. This is where we're going to spend a majority of the rest of the day on, kind of just talking about the different steps that you would take to prepare a permit application and determine if you are going to need what type of air permit you're going to need. So the first step is management of change. That is something that your facility will trigger if you make a change at your facility. Then you'll identify the emission sources and calculate the emissions. Then you'll determine what permits you are applicable to. You'll then do a regulatory applicability, determine the regulatory applicability of the process, the change that you made. Then you'll prepare your permit application. And finally, there'll be a permit issuance and follow-up. So the first step is reviewing your MOC. This would involve impacts on permits as well as impacts on environmental programs. The next step is the emission calculations. You're going to define your project, what is all being affected by your project. You'll identify all of those emission sources that are in this project. You'll then calculate the emissions from the new, modified, or existing sources. And then you'll determine the project emission increases. And from there, you can then determine your permit applicability. The next step is determining your regulatory applicability. So source-wide potential to emit determines whether or not you're applicable to the Title V program. And if that's the case, then you'll need to document all of the regulations that you're applicable to apply for your operating permit. Your project increases determine PSD and non-attainment new source review applicability. So does your project trigger netting? You're going to be working with your project team to discuss alternatives to avoid triggering major source permitting because of the stringency involved with that. And we'll talk in more specifics a little bit later. And then determine if your federal regulations are triggered. You'll work with your project team to discuss alternatives to avoid triggering new federal regulations. Or in some cases, you are triggering federal regulations that require specific control technologies. And so you're going to discuss with your project team to make sure that they are installing the right control devices to meet the federal regulations. Then when you're developing your permit application, it's first important to know if your state has two permits, one for a construction permit, one for your operating permit, or if it's just one permit for both projects as we discussed earlier. The applications should include all of those bulleted items, so a process description, project description, and process flow diagram. Discussion on best available control technology. In some states, they require it for all their projects, both major and minor. In other states, require BACT for just those that are triggered the PSD major source permitting. You'll include emission calculations, maps of the site. Sometimes you'll need to include a map of all the locations of your individual emission sources. You'll have a discussion on the regulatory applicability to verify to the state that your process is designed to meet all of the control technologies in the federal and state regulations, and an impacts analysis. Following the submittal of your application, once you've submitted to your state, you'll tend to go through at least one public notice at the very beginning, and sometimes a final public notice, or depending on your state's requirements, it might be just a final public notice at the very end. The state or federal agency will review that permit. You might have to do some modeling to determine impacts, health impacts if it's an individual state for your individual VOCs, or if it's a PSD permit, you'll do your PSD modeling. Draft permits will then be issued once the state reviews it. They've approved all of your calculations, they've approved all of your control technologies, they approved your modeling. They'll issue your draft permit, which at that point you'll have the ability to review and negotiate your special conditions. And then you'll accept, once you've reviewed the special conditions, you've determined that everything looks okay in your permit, you can then accept the draft permit, and that's when you'll undergo a final public notice, and your permit will then get issued. So the first thing we'll cover first is management of change, and then we'll get into the details of the rest of the permitting process. So the MOC process is something that exists is for a foundation for all safety and accident prevention programs. So every facility should have some sort of MOC process. It creates an atmosphere of no surprises. If the environmental program should be involved in all MOC processes, and that way they know when a process change is occurring at the site that might trigger you needing a construction permit. It creates smooth and stable operations. And the MOC is a critical component of all process safety management programs. It's there. It exists so that you can make sure that when you make a change in your process, all the safety hazards are looked at to determine that the new process change will be able to be implemented with the safety of their employees in mind. So before I talk about this slide, wanted to get everybody's input on their MOC process. So I guess the specific question I like to ask to everybody in the group is, who is involved on the environmental side in approving your MOC? And what role do you have in the MOC process if you are going to be handling the air permitting? So does anybody have any specific examples of how your facility handles MOCs? Anybody? Well, how about a raise of hands? Who works with MOCs on a regular basis? So we got 5, 6, 7 people. And do you actually physically sign off on your MOCs for your air permits? One? Okay. 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 Is anybody else the same way? Do they have multiple people signing off on your MOC, or is it just one specific environmental manager? Okay. So I've worked at some facilities where it's all of the facilities that I've worked with, who signs off on the MOC kind of varies from organization to organization. Sometimes it's a high-level environmental manager that signs off and talks to all the employees that are underneath him to make sure that they have their programs in place before he signs off on the MOC. And other facilities I've seen, they want the specific air guy to sign off on whether or not an air permit's required, or they want the specific water guy to see if there's any wastewater issues that need to be signed off. So I've seen it both ways, and I've always gotten different answers on both sides of that. And there's really no right or wrong answer to that question. It's a matter that as long as you know that the MOC process exists, and if you're the one that's doing the air permit and you're seeing those MOCs to determine if you have to do an air permit, that's what's most important. One other question I always ask is, if you are the person doing your air permitting, do you sign off on your MOC before you receive your air permit, or do you sign off after you've received your air permit? Very good. I always recommend that the MOC is not approved until after you have obtained your air permit, because that way the change doesn't occur before you've received your construction permit, and that construction permit is required before you can begin construction. And I think that was the first time I've heard it from somebody that says there's an initial sign-off that says, yeah, we can do this project, but not until we have our air permit. I think that's also a very good step to have. That allows your process group to go on with the project and developing the details of that project while you go and obtain your air permit. So MOC's impact on air permits. Specifically, there's a lot of things that you want to look at within your if you are the one that's reviewing your MOCs. Changes in emissions. So you want to identify any new emission sources. Identify changes to existing emission sources. Determine if there's any downstream emission sources that are affected, and determine if emission sources from utilities are affected. So what this means is, let's say you're working at a chemical plant. They have a process change that they're going to debottleneck part of the process that allows them to make more. And so the obvious answer to the first two bullets is, they're going to have increases in the process vents that you've already identified. But what often gets missed is the downstream emission sources that might be affected. Well, you've debottlenecked part of the process, so you need to identify, will there be an increase in loading as a result? You're going to be able to produce more of your product, so we need to make sure we account for those downstream emission sources like the loading. Same thing with storage tanks. You're making more product, or you're going to store more material in your storage tanks, which will result in emission increases. The other one that also gets missed quite often is whether or not utilities are affected. If you have a boiler at your facility that is producing steam, and the this debottleneck is going to require additional steam going to the unit. You need to account for the emissions from that boiler that's now going to run more hours out of the year or at a higher firing rate than it has been. And so that's an affected source that we would need to identify. Another thing that you'll be doing if you are reviewing your MOC process is you'll also want to identify changes in permit conditions. So if you have an existing permit for your facility and an MOC comes through that they want to change how they are monitoring data from, let's say, a flare. Well, if you have a specific requirement in your permit conditions that states how you're supposed to monitor your flare emissions, you want to you need to make sure that the change that they want to implement is still going to meet your permit conditions, or tell them, no, they can't do this project because it's in violation of our air permit. The third option with that is if you're changing how you are monitoring your emissions, you may be able to go into your state agency and say, look, our process group wants to have a more efficient way of monitoring our emissions. They want to implement this monitoring strategy. It's more accurate than our previous monitoring strategy. And a lot of times, if it's as good or better than what you were doing before, the state agency will have no problem approving updates in your permit conditions to allow you to make those types of changes. So that's a bullet point that's probably a little more rare in terms of the MOC process, but it can occur, and that's something that you should look for. Another thing that might trigger an MOC process is administrative changes. Let's say plant manager is leaving the facility. There's a lot of times I've heard of an MOC being issued for changes in the administrative personnel. In this case, the person that's signing off on your permits and certifying that all the information is correct might be your plant manager, and if he's leaving, that's something that will affect how your facility signs off on your permits, and so you'll need to go and submit forms to your state agency to change who that person is that is authorized to sign off on your permits. So those are some things to look at with the MOC process. Another thing that might happen is compliance program updates. So outside of a permit change, the way your facility complies with the permit condition may change. So for example, site operating permit updates, new monitoring and record keeping added to compliance procedures, assignment of a new or modified staff responsibilities. So with those three bullets, outside of changing how you're monitoring, you might, maybe you have a fixed roof tank at your facility and somebody says, well, we want to, we have the ability to reduce the emissions from this storage tank by recovering the emissions from in a scrubber or something along those lines. And so the way you are complying with a federal rule, in this case NSPS KB is the more popular tank regulation, you would have to submit an update to your operating permit, and it would change how the types of records that you keep, the types of monitoring that you'll have to do with installing that scrubber. A lot of times when that happens, you're triggering, the reason why you'd be triggering something like that is you're doing a separate project that's increasing emissions other places in your process, and in order to balance out the increase in emissions, they are adding on these different control technologies onto some easier sources like storage tanks to reduce emissions so that the increases aren't as big. And so looking at the project, identifying how you are complying with a specific regulation is something that would be caught in the MOC process, and specifically with your compliance programs. As I stated before, once the NOC process will be completed when somebody is signed off and want to sign off after the permits are obtained or verified to not be affected, or the compliance programs that you have in place have been updated to account for those changes. So with that, we'll move on to identification of emission sources, and I'll turn it over to Matt.
Hey y'all, so we're gonna step through source by source of frequently found sources at these different types of facilities in the chemical and oil and gas facility. But before we did that, I know we introduced everyone real quick, but I was just gonna get another feel of who's who. So can you remind me who's in oil and gas, that's refinery and midstream, that kind of stuff? Who's in like chemical? And then who would be other? So there's like 4 of you that don't fall into either other, chemical, or oil and gas?
Consulting.
Consulting, okay, that makes sense. All right, cool. So when you're talking about why you need to identify these sources, you first need to identify whether the source that's going to be in your permit is a new source, a modified source, or an affected source. So new is pretty obvious. Modified has a very specific regulatory definition. So you need to look at your state definition of modification and also the federal definition of modification. So the federal definition of modification will be a physical or operational change that results in a significant increase in emissions, a net significant increase in emissions. That's where the netting comes from, that net significant increase. That's why we have a contemporaneous window. And then your state definition of modification may vary, right? So we don't have that net in our Texas state definition. So any increase in Texas is a modification if it results from a physical operational change. Also, an emission of a new pollutant will trigger a modification. So you have to evaluate the emissions from those sources. So we'll be talking about how you evaluate those emissions source by source. The other sources that you have to look at are affected. So Jim's gone through that. Can anyone remember what an affected source is? That's not a downstream. Yeah, got an example? Anybody got an example? A bag house. So a bag house would usually result in an actual increase in emissions. So a bag house is tricky. Usually like a downstream would be like a boiler or something. So an affected source, we talk about whether you're increasing the potential or not. So a boiler is a great example of an affected source because usually boilers operate well below their PTE. So you're going to increase the utilization of a boiler, but you're not actually going to increase the authorization of the boiler. So that's going to be affected because its emissions are going to increase, but its potential is not going to increase. Where a bag house, usually you've permitted that bag house at its potential, and if you're going to debottleneck, then its potential is going to go up. Does that distinction make sense? Okay. Some other places that you may see that is a tank. A tank kind of was a classical definition of an affected source. So the actuals do matter, but they matter for different reasons, right? So they fall into different categories. So you look at affected sources when you're looking at that federal applicability, like whether you're PSD. And I'm going to be going through source by source talking about how you calculate emissions from the sources. So we have to calculate the emissions to see how those emissions change for federal applicability. But that limit on your permit isn't going to change for an affected source. Okay? That's the main distinction, right? On a modified source, that limit on your permit is going to change. For an affected source, that limit on your permit is not going to change.
But you still have to you still have to calculate its emissions to see whether you triggered PSD or whether you triggered a non-attainment project. That's right. That's right. Yeah. So like boilers, you may be firing it at 40%, right? But you're going to build a new unit, and now you're going to be firing it at 70%, right? But it was permitted at 100% the whole time. But you have to look at that difference between 30 and 70% for federal applicability and see whether that 30 to 70 tipped you over into PSD or non-attainment. Go ahead. We'll go into that a lot later, but yes, generally. So NET is talking about unrelated projects to the project that's going on, both elsewhere at the site and also at a different period in time. So within the last 5 years and somewhere else at the source, at your entire facility. Well, no, you have to do both in Texas, right? So the reason that modification is important is if you modify a facility, then you have to evaluate BACT, right? So that means that your emissions have to, like for NOx, like you have to meet the NOx BACT limit dependent on the type of emission source. But for an affected source, you don't have to meet the BACT limit. So knowing which category it falls in is important because it triggers BACT, or it will change your permit limit, or it goes towards federal applicability or not.
And what you're talking about now is all just step one of the netting process, not step two contemporaneous. Right? So you're just talking about the project modified or affected. You're not going into the prior project.
Well, I'm sort of talking about both, right?
In Texas, it's important to know that the
Yeah.
reason why the definition is different is because they require a minor source permit for all sources that are changing at your facility. So in other states, they won't have that definition because in some states they don't require minor sources to be permitted. In Texas, anything that is modified and anything that has increased emissions requires a permit. It's only once you get to the federal permits, the PSD non-attainment permits, that you have the option to net out, is what they refer to it, net out of those requirements. So if you have other projects going on at your facility over the past 5 years, you can that result in reductions in emissions. You can get out of your PSD and non-attainment permits if you're below those significant impact levels. So one of the reasons why Matt brings up that point in the differences in the definitions is that it comes into play in determining the type of permit that you're going to need. In this case, it's a state-only permit requirement when you have any type of modification process.
And we'll be coming back to the different types of permits, and we'll also be coming back to the netting concepts. I just wanted to introduce the reasons that we're doing emission calculations in the first place, right? We do emissions calculations for a variety of reasons, and we need to know where those emission calculations are leading us. All right, so let's talk about those emissions calculations. Well, let's talk about the different sources that we'll do the emission calculations on, right? So your main sources are going to be your process vents. Process vents are usually routed to control, so your different types of control are going to be combustion devices, which include flares. This will also be thermal oxidizers, vapor oxidizers. There's a variety of other combustion devices. You can also route vents to, or tank vents, or a variety of different things. You can route to scrubbers, both water, if the thing that you're trying to control is soluble, or if you have an acid gas stream, you can route it to a caustic scrubber. You can route VOCs to carbon canisters, and then particulates will go to like a dust collection system, which can be a cyclone or a bag house. There are water dust collection systems, but you don't see those as much. So that's your vents and your control devices. Other emission sources are going to be other combustions, which will be heat generators. That'll be your boilers and your heaters. Mechanical sources, which is also combustion sources. Those will be engines and turbines. This is not non-electric engines and turbines, right? The emissions from those will come from the source of the electricity. Loading is a source of emissions. We'll talk about how you calculate loading emissions. Tanks are a large source of emissions. Each tank is its own source. Piping and fugitive components, that's what we call LDAR. Cooling towers is a source of both VOC and particulate. And then the wastewater treatment plant. Like I said, process vents are normally sent to control depending on their size. So when you're looking at a process vent, you calculate the flow rate and the speciation. So to get that flow rate, you need some process knowledge. Usually a process engineer gets involved. You'll rope in a process engineer to get the flow rate from the process vent. Or you can do mass balance or a heat balance. So you can, if it's a more simple process, you'll know what the mass going into a process is, what the mass going out of a process is, and then what's lost or created through reaction in the process. And you can do a mass balance on the process, and whatever is missing is what was lost through the vent, right? There's other sources of this. Tanks are an example of a vent, right? Tanks will have a vent. Loading is a process vent. You can also use the ideal gas law. If you know the size of your vessel, you can think of it as a vessel purge. And you can also use the ideal gas law as sort of a red face test. If you're doing a mass balance, you can check it against the ideal gas law and see whether you're within the right range or not. So the process engineer, or you, if you have enough knowledge of the process, can go back and look at historical flow data. There's a variety of different modeling softwares that you'll see, dependent on the type of industry, but they'll know the modeling software that'll tell you how much is emitting at the process vent. And like I said, you can also use the mass balance to get the flow rate. Now, you need to pay attention to the basis of the flow rate. Don't fret, this is just a very simple equation. We can all use this equation because some of the flow rates will be based on mass and some of the flow rates will be based on volume. We are, in the permitting realm, interested in the mass that's emitted, not the volume that's emitted. So we need things converted over into mass. So if you're close to standard conditions, then this is your equation. To get from the flow rate the flow rate V, that's the flow rate volume, to get from that to the flow rate mass, then this is how you do it. If you're ever in a project, just be like, hey, I went to 4C and he gave me the equation, and plug in your thumb drive and there it is. All right? Or you can put it on a Post-it note on the edge of your computer like I do. All right? So that's how you get from the volume to the mass, because we need the mass emission rates. So here's another thing that you run into a lot. A process engineer will be like, oh, the thing emits 1,000 scuff, or 1,000,000 scuff. This is a 1,000 scuff. Here's our composition, right? Usually the compositions are like 12 lines long, but we just simplified it. And then, of course, you need to go to the agency and say how many pounds of each one of these constituents is emitted, so that you can do a health effects impacts analysis. So here's a simple calculation of how you do that. The mole fraction is going to be the same thing as the volume fraction. That's Avogadro's law. So you basically take the mole fraction times the flow rate, and that'll be the fraction of each species. And then you put it through that same equation, and that gives you the mass flow rate. Now, I know I'm moving through this real quick, but if you have any specific questions, we can go through it step by step. But just, I know equations make people's eyes gloss over, so I'm trying to move along. All right, but I wanted to give this to you as a resource because this is something that comes up frequently when you're doing emissions calcs. You'll get a flow rate in volume and you need it in mass, and you'll also need it speciated. The other thing that comes up is you'll get the weight percent instead of the mass percent. Like I said, Avogadro's law says that the mole fraction is the same thing as the volume fraction. That is not true of the weight fraction. So we provided the equation to get from the weight fraction over to the mole fraction. You just have to calculate the total molecular weight. That's the linchpin, the cornerstone of the whole equation, is calculating the total molecular weight of your stream. And then you can convert back and forth quite easily. Excel is very helpful in doing this. Like I said, you can also use PV equals nRT. So another main source of emissions is MSS, which stands for maintenance, startup, and shutdown, or SSM, which is the same thing. And this involves a lot of like vessel purging, for example. So if you're just purging a vessel, then you can take the volume of the vessel and the pressure that the vessel is at when it's purged and calculate the number of moles that are in that vessel, and then assume that all of those moles are emitted over a certain period of time, and that will get you the flow rate. So that's what's done here. We start with the PV equals nRT example. I think I have a laser pointer. We start with the PV equals nRT example, and then we convert that to find moles, and then moles times molecular weight is going to be your mass emission rate. Does that make sense? Yeah. So that'll be your, well, that's your mass emitted, and then you have to know over how much time. The safest thing to assume is that it all emits over an hour, and if you can't pass impacts, then you can talk with your process engineers about how long it will actually take to purge the vessel. But it's safer to just assume that it emits over an hour and see if you pass impacts, and then if you can't, then you come back.
Another scenario outside of MSS for this would come in handy is if you operate a batch chemical process. Because you're not operating a continuous process, you're going to be filling a reactor up and purging that vapor space in that reactor to a control device. And that's another example where you would use the ideal gas law as well.
Yes.
I think SSM is a little bit different than I think it is. So SSM startup, shutdown, and malfunction.
Yeah, it includes malfunction, but the calculations are done the same. Yeah, so SSM is like the federal definition and doesn't include maintenance, but the calculations are done the same, as far as I know. I actually haven't done a malfunction shutdown, a malfunction calculation.
They're done the same, you just can't permit a malfunction or an emission event. So
Yeah.
What you do is you try to permit your maintenance at a level where you think you can control it. But the other stuff, when you can't control what's going out, it's a malfunction, you can't permit that. Right.
Well, you report it based on the emission. So there's a reportable and a non-reportable quantity. So it depends on how much actually happened. So if you're a major source, then you put your non-reportables on Title V. And if it's above a certain threshold, which I can't remember now, then you have to report it. Does that?
And that'll vary by state on what the reporting requirements are for your unauthorized emissions.
Does that make sense to everyone? That you don't permit upsets, right? You permit normal operations. And if an upset does occur, then you calculate how much emissions there was during that upset. And then you look at the reg to see whether that's above the reportable quantity. Yeah. Yeah, so but all of those go on the Title V report. But whether you have to report the upset immediately to the agency as a reportable upset depends on the amount. Okay. Hopefully, if you're at a facility that big, they have a system that will do that calculation for you. Because I think usually the reporting requirements are very rapid. It has to be reported very quick. Okay, so control devices. So these streams that we're talking about, right, you can calculate the mass emissions and the mass emission rates from a stream, right, from a reactor, from a process vessel, and they will be routed to a control device. So that the actual emission rate will then be the stream that's routed from the unit to the control device, and you just then multiply that by either the DRE, which is the destruction removal efficiency, or the RE, which is the removal efficiency of the control device. So like a flare is classically 98%, so you'll multiply your flow rate by 0.02, and that's the amount that got emitted as VOC. Now, since you're burning it, you're also going to have the combustion byproducts, which is NOx, CO, and PM, and those will come from an emissions factor. So each combustion device will have its own emissions factor, or you can talk with the combustion device manufacturer. So you can look to guidance for the emissions factors, or talk with your vendor of your combustion device if it's new. And you'll want to if it is new, you'll want to check that against BACT to make sure that you're going to meet BACT before you procure the contract. The only trick there is flares are smokeless by 60.18, so we don't permit PM from flares, but we do permit PM from all the other combustion devices. So you can use the PM factors in AP 42, for example. SO2 won't have a emissions factor. SO2 will be a mass balance on sulfur in your stream, and then a fraction of the SO2 will convert to H2SO4, depending on how much it is. So for flares, like I said, the destruction removal efficiency is 98% for almost everything except for your 3 carbons, which will be 99%. For your other combustion devices, you can get pretty high with some of the thermal oxidizers and the vapor combustors and catalytic things. You can get up to 4 nines. So 4 nines means 99.99. That's what 4 nines means. So 90% is probably pretty low. That would be, I don't know what 90% is.
Inefficient scrubber.
Well, a combustion device.
Oh.
Yeah, but you talk with your vendor to figure that out. Scrubbers are going to be based on the solubility of your product, and again, talk with your process engineers, and they can help you figure that out. Are there any questions about that? Who in here has done permitting on a combustion device before? Okay. Did y'all run into any snags or anything that was surprising? Lessons learned?
I think I was mentioned to the group is that if you try to get more than 99 on the flare or 98 on the flare, you might have to use a lot of.
That's a good point. Yeah, that's pretty solid. That comes from years of regulatory precedence. So to get more than that is going to be very difficult. Correct. Destruction removal efficiency. What's that?
I'm thinking the John Hank handbook.
Uh-huh.
Combustion efficiency and destruction efficiency.
Yes. That's right. Mm-hmm. Yes. Yes, you do. So I believe that's coming. So for the NOx and CO, they're going to be off of factors. So for the DRE, for the VOC, we use a DRE, which is the flow rate that's going to the stream, and then a fraction of that will be emitted. for the NOx and CO, what you do is you take the heating value of the stream plus the heating value of any assist gas, which is usually natural gas, and you add that up, and then you multiply that by your NOx factor. So your NOx factor, you know, for this here, your NOx factor for a steam assist high BTU flare is 0.0485 pounds per million BTU. So you take the heating value of the waste gas stream plus the heating value of any assist gas, which will be your natural gas that's supplied with the stream. And however many BTU that is, you multiply that by your emission rate, by your emission factor, and that gives you the emission rate of NOx. Same thing with CO. Yes?
What I've noticed is, if I can say this right, because MSS has become such a big, obvious thing in the past 5 years or so,
Yeah.
we find that our flares occasionally go from low BTU flares to high BTU flares.
Oh, okay.
So you're permitting, and, you know, in the olden days, you just did one or the other. You're a BTU flare or you're a low BTU flare.
Mm-hmm.
You can actually go between them.
Mm-hmm.
What would you, I mean, I've always thought the most logical thing to do was permit the worst case. CO is higher for one, NOx is higher for one. And use factors, pick the highest factor. Then you wouldn't have to worry. I mean, do you see what I'm saying?
I do see what you're saying. I haven't taken a close look at that.
If your normal operations are for a low BTU flare, you'd want to use the low BTU combustion factors for your normal operations. And then your MSS activities are going to be very infrequent and one-off situations that you'll be calculating those emissions separately, and that's where you would want to use the high BTU combustion factor. I also,
Sometimes they occur simultaneously.
and
Yeah.
sometimes they occur simultaneously, and that's the situation that I work with facilities where their flare is used to control process vents from several different processes,
Right.
and some might be not
Shared.
running, and some might be running, and sometimes they're all running at the same time.
Right.
And so I usually use the worst case, like you said, the worst case emission factor for the bad emission type. And so sometimes, looking at the steam assisted, you're going to use the low BTU NOx emission factor and then the high BTU CO factor.
And you have done that.
And I have done that. And
See, that's it.
I don't see the agency having a problem with that.
Okay, because that's the only way I think you could cover your high heat.
right, and as long as when you're describing your mission calculations and procedures to your agency, and say, look, we have a variable BTU flow rate going to this flare, so we took the worst case emission factors.
Mm-hmm. Then you can pass everything. You should be able to, well, it's the NOx.
Right.
Good question.
Yeah. So does that make sense about the different methods of, even though it's the same device, you're going to calculate the byproducts of combustion in a different method than you calculate the VOC? Calculate VOC off of a mass and then a fraction destroyed. You calculate NOx off of the heating content. NOx and CO. And there's a variety of guidance. Is this equal to? Is that better? No. Okay. There's a variety of guidance on. It's bothering me now. There's a variety of guidance on flares. There's a bunch of sources. There's a TCEQ guidance. There's an EPA guidance, and there's also Petroleum Refineries Protocol guidance on flares to get you through flare emission calculations. And also just, I've been talking about byproducts, just in case you haven't seen this in a while. Remember that when we're talking about combustion, this equation is for complete combustion. I'm going to walk. This equation is for complete combustion, right, where a hydrocarbon plus oxygen goes to CO2 and air. The NOx comes from, this is what we call thermal NOx, right? Because air is going to be, there's a lot of nitrogen in air. I don't remember, 70-something percent. Yeah, 70-something percent. So there's a lot of nitrogen just in the atmosphere. So when you combust the nitrogen in the atmosphere, you form NOx. That's thermal NOx. There's also fuel-based NOx. So if you have a high nitrogen stream, like if you use nitrogen as a carrier gas to get your waste stream to the flare, or to get your waste stream to a thermal oxidizer, then you'll want to add another line here to include the fuel-based NOx. CO comes from incomplete combustion, right? This is just like a big candlestick sticking up in the air. So you don't actually reach this complete combustion. The byproduct of incomplete combustion is going to be the CO. This is the equation that I said that you do the mass balance to calculate SO2. So it's just a stoichiometric ratio between H2S and SO2. And PM will come from soot, so it can be both carbon black, it's just black carbon, or it can be the non-filterable carbon can also be like autonucleated carbonyls, like high viscosity compounds, so that'll be like your PM 2.5. And then you can also form some GHGs from flares, or combustion devices in general. So heaters and boilers are also combustion devices. Boilers can be used as a control device, but they're not typically. And emissions vary based on the type of fuel, based on the firebox configuration, the time that the fuel is in the firebox, how the nozzles are designed, the size of the firebox, a lot of different factors, and each boiler will have its own emissions factors. There's also emissions factors in AP 42. You can see chapter 1.4 or 1.3 if you're using a liquid fuel. And then the liquid petroleums are going to be in 1.5. If you have vendor data, then use your vendor data. Or if you have stack testing, then use your stack testing. And then if you're at a refinery, then you can look at the refinery protocol as well.
One note on that emission estimation protocol for petroleum refineries, that was developed out of the 113 requests that were issued to the refineries a couple years ago. And a lot of states have their own guidance documents on how to calculate your emissions or your emissions inventory. And this estimation protocol is developed very similar to that your emissions inventory guidance documents on how to calculate emissions, and provides a lot of background information on how to calculate a lot of emission sources.
How many of you have boilers or heaters at your facilities? These are popular sites. I'm surprised it's only that many. Engines and turbines are like boilers and heaters, where you get instead of producing steam, you're producing mechanical energy. The emissions factors are going to be based on the operating conditions, the air to fuel ratio. I mean, even the outside temperature will affect these. You can see the engine type, the fin type on a turbine. They're very variable. They change a lot. So when you're trying to calculate these, you can turn to AP 42, but usually they're provided by the manufacturer. So I would turn to manufacturer specs, especially on the turbines. But the engines, the manufacturers will still provide it, or you can rely on AP 42 factors for this. For the big boys, you can use stack testing, power generators, and whatnot.
I've even heard of some engines having same model numbers having different emissions profiles just because they were operated differently. That's why a lot of stack testing, you'll probably permit using manufacturer specifications, but after you stack test that engine, you might want to update your authorization to match the stack testing, because each individual engine can vary so much.
And then they also change them out. You'll change out the components of a turbine on a maintenance schedule, and its emissions factors will change. So these turbines are very variable. Does anyone in here deal with turbines in the electric utility? You have But sometimes you'll have like a cogeneration facility at your site, and that'll, or compression in midstream will have a lot of turbines as well.
You do have to be, you know, with the 1 hour, two standards, yeah, that you have to pass, and the CS 2.5, you know, going to 1842 gives you such conservative numbers, such very big numbers,
Yeah.
and you might have problems passing with that.
I saw a similar thing with midstream sites because they're not big. They'll have a lot of compression and they're small sites. So that's a very good point.
I've also seen people authorize their engines using emission factors in specific federal regulations, because they know they have to meet that federal regulation, and the manufacturer doesn't necessarily have the emission factors to provide them, but they've certified that they will meet that federal regulation, so that would be another option. Yeah, I mean, when you're calculating emissions from engines, if you calculate with AP42, you might have 50 tons of emissions, of NOx emissions from one engine. Then if you use the manufacturer specifications, it'll be 10 tons of emissions. Might be down to 5 tons. That could be the difference between triggering DSD non-attainment permits and state-only permits.
Loading is an interesting case. Loading can range anything from, a one-bay truck loading facility all the way up to, bigger than Panamax. I can't think of whatever the word is, vessels out on the ship channel. So loading emissions come from displacing vapor in the vessel. So if this is your vessel, this one's already loaded, but if it's empty, then it's full of vapor. And as you fill it, then those vapors have to go somewhere. So the emission rate is going to be, it's essentially calculated off of PV equals nRT, but that PV equals nRT has been simplified for you already. Let me jump ahead to this equation where the loading loss is going to be 12.46 times the saturation factor times the vapor pressure of the material times the molecular weight over the temperature. So the saturation factor is going to be how the loading is performed, right? If you're doing splash loading, then the saturation factor is higher than if you're doing submerged fill or bottom loading, because you'll generate more vapor per load. And then you'll use your molecular weight, your temperature, and the vapor pressure of your material. Now, when you load the vessel, there's two factors beyond that you have to consider. There is a collection efficiency and a control efficiency, right? So some loading can be performed just routed straight to the atmosphere, but dependent upon the depending upon the vapor pressure, some loading has to be controlled. So if you're going to control it, then you have to think about both what the destruction efficiency is of your control device and also how much of the vapors actually get captured. So that depends on the vessel. So how much of the vapor gets captured depends on the vessel. So if you follow MAERT level testing, then you can capture 99.2%. If you follow NSPS level testing, then that's going to be 98.7%. Marine vessels, ships can be captured to 95% or higher if you do testing. And then no testing is 70%. So you can also do vacuum loading, which is where you draw a vacuum on the vessel, right? So if the vessel is under vacuum, then no vapors are going to escape because the pressure inside the vessel is lower than the pressure outside the vessel. So if there's any leaks in the vessel around the hatches or around the welds or whatever, then air is going to be drawn in instead of being pushed out as you're loading. So vacuum collection is 100% collection efficiency, but you can't vacuum seagoing vessels because of Coast Guard rules. Although you can vacuum barges. I don't know what the deal is with that. Talk to the Coast Guard. You have to look at, so you do the loading equation and you calculate the loading losses, and then you multiply that by the collection efficiency, and that's how much gets routed to the flare, and then you multiply that by the flare's control efficiency. All right? Does that make sense? So the saturation factors are in the slides, but they're also in AP 42. There's the loading equation, which is in the slides. And then I guess I didn't know that loading was in the petroleum guidance document. Do they have special loading at refineries?
It's the same as AP 42.
Okay. Are there questions about loading? Yes.
All right, so if we go back to that last equation, so if I'm loading and I know, what's not really testing, all of it, if the result of that and multiply it by, 30%,
No, multiply that by 70%. So that's how much gets routed to, well, if you multiply by 30%, that's the uncontrolled portion. So we call those loading fugitive losses. So that's what is emitted at your loading rack, right? So like your loading rack will be an emission source, and then your control device, so let's say it's a vapor oxidizer, will be an emission source as well. So you do this equation, and 30% of this equation gets emitted at your loading rack, and then 70% times 0.01, right? So 0.07 will be emitted at the vapor oxidizer. No, that's a different, they're loading loss fugitives. They're not piping and equipment fugitives. So you can also call them uncontrolled loading emissions. So we call them fugitives, but it's different than your piping and equipment fugitives. Yeah, piping and equipment fugitives will be calculated. But these are emissions that are lost around the manifolds of the truck, right? So there's like a truck in a loading bay, and as you pump things into it, there'll be leaks in the truck and leaks around the manifolds and leaks around the connecting equipment to the truck. That's different than other lines in the facility where there's leaks around those valves, and they're two different categories.
So are they accounted for, or are they represented in the application?
Yeah, but you won't do like for all those in the facility, you'll have to do like leak testing. Well, you may have to do leak testing. At a large facility, you would have to do leak testing, and do the LDAR stuff. But for the truck uncontrolled emissions at a loading rack, you don't do those leak testings. You just represent those emissions and make sure that they pass impacts. Did that make sense to everyone, the distinction? We'll talk about fugitives in a minute here. So if that's confusing, bring it back up, and I'll talk about that distinction between uncontrolled loading losses and fugitive emissions. Because they function in the same way, but they're thought of separately in permitting. Okay. We're on fugitives now. So fugitives are losses at valves, at flanges, at connectors, at pumps. And when the permitting program was conceived, these losses weren't really something that was even thought of, right? Each one was thought of as de minimis and was so minor that it wasn't important. And then, people realized that, well, when you add them all together, they're a significant contribution to emissions. So a little leak here, a medium leak here, a leak here, a little leak here, a medium leak here across a refinery adds up to a lot of emissions. So that's where the fugitive program came into existence. So Now you have to estimate emissions from all of your fugitive components, which will be, you count up all the flanges, all the valves, all the compressors, all the pumps in your facility, and each one has an emissions factor. And then you have a different monitoring program. So the EPA document came out in 1995 with the refinery factors. SOCME, which you hear very often, stands for Synthetic Organic Chemical Manufacturing Industry. These are your chemical plants. And then oil and gas production. The TCEQ came out with a guidance document in 2005 that split up SOCME into SOCME with ethylene and without ethylene, and also provided control efficiencies. And it also lists like oil and gas terminals and a couple other facilities that aren't listed in the EPA document. And then those got incorporated into the EPA by reference.
One thing that to note on those TCQ stocking factors that they developed, what they did is they took the EPA guidance document from the stocking average, and they the TCQ or the EPA data on that showed that fugitive components that dealt with streams that were high in ethylene leaked at a much greater rate than those without ethylene. And so they took the data and estimated an emission leak rate for the components that had ethylene and those that did not have ethylene. And now they're used pretty much industry-wide for making petrochemical facilities.
So the emission calculations will represent a leak rate. You calculate a leak rate, and then you calculate a control efficiency in the same way that you had a control device. But instead of a control device, it's a control program, which is a person going around and finding the leaks and tagging them and then fixing them by either tightening the flanges or replacing valves. You have to calculate a speciated a speciated emission rate. So you know the total emission rate, and then you know the speciation of the stream and the pipe, so that's your speciated emission rate. And the pipe may not be all VOC. So the factors give you a total emission rate, and you need to know the speciation that's in that pipe or in that unit, and that will give you the VOC emission rate. So this is an example of the emission factors. So what you would do on a fugitive calculation is you would take your type of facility, or you would probably do it unit by unit if you're at a large facility. You would take your unit and add up how many valves you have in gas or vapor service, how many valves you have in light liquid service, how many valves you have in heavy liquid service, how many pumps you have in light liquid service, etc. And you multiply them by their appropriate factor, right? So if that unit is in a SOCME without ethylene service, look at the guidance document to see the distinction. I think that this is less than 20% ethylene. This is
Less than 11.
less than 11. This is greater than 80, 85. Yeah, so I don't remember. There's a guidance document that precedes these that tells you which one to use. So you multiply them by the appropriate factor, and that gives you your total emission rate. And then you multiply that by your speciation to get your VOC emission rate. And then, here's the other types, right? So if you're at a refinery, you would use these factors. If you're at a petroleum marketing terminal, you'd use these factors, et cetera. And then you take that emission rate times your control efficiency. So this will be what LDAR program you employ. So 28 VHP is usually BACT in Texas. So for each gas and vapor valve, you get 97% control efficiency by walking around and saying, okay, this one has over 500 ppm, so I need to tighten the bolts on it, and then come back and check it later and be like, oh, it's still over 500, so I'm going to tag it. Whatever the leak detection program is. You don't get anything for heavy liquid. You only get 30% for flanges. There's a big LDAR program. I think that has like a 2 or 3 day training track at this at this conference. LDAR is an entire world. So that's how you calculate emissions, though, is you can get higher efficiency on what? That's right. So like 28 LEAR, 28 layer, is right what you would use in a non-attainment area, and it has higher efficiencies than VHP because it requires higher efficiency, higher frequency testing. You have to go around and check your valves more often, and I think in some instances it has a lower leak definition, but I don't know all the ins and outs. So you have different options in what you choose. AVO, you can only use this in certain instances. The guidance document speaks to it, but you need something that can be smelled.
It's important to know that all these control efficiencies are only accepted in Texas at the moment. These are TCQ published control efficiencies and correspond to a monitoring program in your special conditions. Within the other individual states, I haven't yet found any published control efficiencies, but what we've found is that that 28 VHP program is very similar to a HAN type monitoring program at most chemical facilities. 97% control is usually associated with quarterly monitoring. 30% control is usually associated with annual monitoring. So you can use these control efficiencies, but you'll have to justify it to your state agencies. Yeah.
One of the databases, I see a lot of much better than what you get on
Yeah, and that's a very good point. A lot of states will allow you to use that kind of data specific for your emission inventories. You can certainly justify using those types of control efficiencies in your documentation during your permit application. If you have a history of having better than average leaking components, you're good at making sure your components don't leak. That would be a good example of having the background information to justify using higher control efficiencies. And one of the reasons why you want to do that is, again, is that trying to get out of your major source permitting threshold. The difference between having 97% control efficiency and no control efficiency is a huge impact on the amount of emissions that you can generate.
Do you actually know the TCQ allowing a higher control efficiency than 97%? Because I don't have any.
No, they're very inflexible on their monitoring programs. Yeah.
But if you're in a state that
Louisiana, on the other hand, is that.
If you have something like super database data, then they'd probably look at it, but they're pretty inflexible.
I will mention that I've been through a couple of meetings lately, and we've been looking at like projects and costs.
Mm-hmm.
And basically, the cost for leakless components is kind of drop through the floor.
Okay.
And a lot of folks are telling me that it's no longer a barrier to go through. So if you're doing the project maintenance stuff.
Okay. Well, now I'm talking about for permitting. I don't have as much experience in the EI realm, but
They have elected commission members on the EI realm.
Right.
They work to do it for permitting.
yeah, for permitting they're not super flexible.
So if you're trying to avoid TSD in a big project, then you really tough. Like just using it alone.
Well, you can use these.
Right.
You know, like you can switch from 28 VHP to MID to layer, but if you're trying to use a database or something, they'll listen to you, but it's going to be a hard sell.
And that's why I bring up the point. It varies from state to state on the piece of emissions and their use of control efficiencies. Definitely, that's something that if you are trying to get below major source thresholds, call your state agency, somebody in the permitting group, and see if they have any guidance on calculating using control efficiencies and what they will accept and won't accept. could voluntarily just move your 30% connector to VHP to the higher, not 30. Yeah. I think that's the limit.
Well, you can't move just the connectors. You'd have to move the whole unit.
Yeah.
If you, in VHP, you don't have a connector. Right. I mean, you have your 30% starting out. I mean, you can voluntarily move them up. You know, if you're already going to have a program, you have your own valve in there.
Yes.
Yeah. I mean, that's really the only way I
Yeah.
don't mean to turn into
No. I think these are, you know, the LDAR gets super nitty gritty, but it will substantially contribute to emissions of certain projects. So sometimes digging down is important. Another source is cooling towers. So cooling towers, you get VOC leaks by the cooling fluid leaking into the water, or you can also get PM emissions by, I mean, you do get PM emissions by a drift off the cooling tower liquid having TDS in it. So as the TDS in it, there's dissolved solids in the drift that gets blown off of the cooling tower, and so as the water evaporates, then those dissolved solids are left behind and form particulate matter. So that's the source of the VOC and the VOC and the PM. Emission rates are based off of AP42 factors, or there's other ways to calculate PM. So just use, it's mainly factors. And the main driver of that is going to be your flow rate, your circulation rate in your cooling tower.
When I first started at Sage, Texas didn't require PM emissions to be calculated in your permit if that cooling tower was located far enough away from the fence line, because the particulate matters would fall out before they reach the fence line. But they've since taken a different stance on that, and now they require it from all cooling towers, and that's pretty common in most states. And if you've ever parked a car near a cooling tower and for a day and come back and see a film on your car, that's the particulate matter that's settled out of the cooling tower water.
Yeah. This is more on what I just said. So storage tanks can also be very big depending upon your facility. Some facilities are only storage. So, you know, depending on what your facility is, they're only storage. So there's different kinds of storage tanks. There's a fixed roof storage tank where essentially you treat it as loading, right? The emissions are from displacement of vapors. There's a floating roof storage tank where you're going to need some type of calculation, right? Because the factors in some type of calculation tool, either tanks 4.09 or some other calculation tool, ESP, there's a couple others. Because the factors in Chapter 7 of AP42, there's a ton of them. There's both internal and external floating roof tanks. Then there's horizontal tanks, and then there's pressure tanks. Like I said, those emission factors are in Chapter 7 for all the tanks. So the main losses on storage tanks, especially fixed roof tanks, are going to be standing losses and working losses. So a standing loss is when a tank breathes. I think I have a tank here. So if you have a tank that has liquid in it, a standing loss is what happens from expansion and contraction. It's called a breathing loss. As the tank heats up, the vapor space and the liquid to a lesser degree expands, and so it comes out the vent on the top, and that's the tank breathing. And then as it cools down at night, then it sucks the air back in, and that happens every day. So that's its breathing loss. Its working loss is when you fill the tank, the liquid level rises and displaces that vapor out. So the working losses are going to be where your highest hour comes from, and also where the majority of your annual emissions come from. But the breathing losses do contribute, so you have to calculate them both. So for a floating roof tank, you have four main types of losses. You have your rim seal losses, your withdrawal losses, your deck fitting losses, and your deck seam losses. You add all those up, and that's how you calculate your annual emissions. So let's take a look at these. So what do you think your withdrawal losses are? Anybody know what withdrawal losses are? This is an internal floating roof tank. Here's the floating roof. The liquid is below it. Vapor space is above it. What are withdrawal losses in a floating roof tank? Anybody dealt with tanks? Have a bunch of tanks at their facility? Yeah? What you got? So that's a seal loss. That's a rim seal loss. The withdrawal loss is what happens when you pull out the liquid, the floating roof lowers, and you end up with a film along the wall and the, depending on how it's set up, but also the columns. Okay, so that's your withdrawal loss. All right, so unlike a floating roof tank where the main losses are when you fill, a fixed roof tank, the main losses are when you fill. A floating roof tank, the main losses are when you withdraw. Because that's when the majority of the liquid will be exposed to the air. The rest of them are just like minor seeps around seals, right? So we have the rim seal loss, and then we have the deck fitting losses, which the deck can either be welded or it can be riveted. And so that'll be a main input parameter to your calculation program. If it's riveted, then the leaks in between each one of these things will be higher than if it's welded. This is the deck, by the way, this floating roof. If it's riveted, then your leaks are higher than if it's welded, which makes sense. And then the seal loss, the fitting losses are like around the little columns, the manifold, et cetera, right? Does that make sense? There's just so many components, blah, blah, blah. The programs are nice because you just put in the size and it tells you how many components are there, and you don't have to put in and count each individual components. And the programs are nice for floating roof tanks. A what? Okay. Okay. I don't know that term in Nardo valve. Okay. A relief valve that only opens above a certain pressure?
Well, it's going to be a little pressure.
Yeah, they're usually at like 0.03 psi. Yeah.
But that valve relief, a guarded valve is a combination of relief valve and back.
Okay.
I think what you're referring to is, so the fixed roof tank calculations, there's a pressure setting on what those valves.
Are you talking about quad O? Like.
What I'm referring to is whether that's an override component. That's what I'm trying to figure out.
Typically no.
Yeah.
That's what I'm getting.
Gotcha. No, we don't count that towards the feature, because that's actually a part of the tank.
Yeah.
And actually, that brings up a good point with fugitive emissions. You're only calculating the fugitive emissions that actually has something in a pipe, and so that valve is not necessarily always seen. You'll get some of the gasket papers that are being stored in that thing, but it's designed to allow breathing losses above a certain pressure, and so it's not designed to hold in liquid like you would see with other or vapors like you would see with heating tanks. Right.
So this is an external floating roof tank. It's the same. Oh yeah, go ahead.
I was just gonna say, so the lunchtime are we going to?
Yeah, I have like 3 more slides. So this is the external floating roof tank. It's the same thing. You have the same 4 losses, but no lid, so the emissions are higher. Right? Emissions are higher for an external floating roof than an internal floating roof, but they're cheaper to build. We also have wastewater treatment. Emissions from wastewater treatment is from basically things that are dissolved in the wastewater. All right, so they evaporate. We usually use Water 9 or ToxChem to calculate emissions from a wastewater treatment plant. So if you ever have to calculate emissions, just go to Water 9 or ToxChem. That's how you'll calculate the emissions from a wastewater treatment plant. There's also MSS emissions. Those are done by event. So some MSS emissions will include floating roof landings, painting, sand blasting. You have to look at frac trucks. You have to look at vacuum trucks. That's going to be more advanced than is for this class. But MSS will be a large portion of emissions calculations now. So don't forget that they exist. All right. So I think we'll go ahead and have lunch and cover the review when we get back. All right. We'll be around for lunch if you have any questions.